Welcome back to Math Zone African Motives. Today, we're diving into how humans have been looking into space for thousands of years, from the earliest stargazers to the invention of the telescope. Early viewing of space, the night sky, has always fascinated people. Long before telescopes, ancient civilizations observed the stars and planets with the naked eye. Rock art paintings in caves across Europe show that people recorded the movements of stars even before writing was invented. About 5,000 years ago, civilizations like the Babylonians, Egyptians, Greeks, and Romans carefully studied the heavens. They created records on carved stones and clay tablets showing constellations that we still recognize today. The ancient Egyptians in particular were advanced in their knowledge of astronomy. Even with simple tools, they calculated the distance from Earth to the Sun and even estimated the size of our planet. Famous thinkers like Plato, Aristotle, and Ptolemy made incredible contributions, shaping the future of astronomy. Astronomy and culture. In many cultures, astronomy was deeply tied to religion and daily life. Priests often served as astronomers, interpreting the skies as messages from the gods. For example, the Egyptians worshipped the sun god Re, while the Aztecs honored the sun god Tonatiuh. In Africa, the sun and moon played important roles in cultural traditions. In Swaziland, the Nkwala festival is celebrated when the sun is at its highest. In Malawi, weddings and ceremonies are often held under the light of the full moon. And according to San legend, the moon is a man who angered the sun. Each month, the sun cuts pieces off the moon until only a sliver remains, before the moon gradually grows again. Across the world, from China to the Aztecs, people studied the stars to understand life and predict events. Arranging stars into constellations, early astronomers noticed that bright stars formed patterns. They gave these patterns names and told stories about them. These became known as constellations. Today, we officially recognize 88 constellations. Some of the most famous include Orion, Centaurus, and Perseus. In South Africa, you can see different constellations depending on the season. One of the most famous is the Southern Cross, or Crux. Even though it's small, its 4 bright stars make it easy to find. The Southern Cross is so important that it's often used as a guide to find the direction of south. Constellations across cultures. Different cultures gave constellations different names and stories. The Khoisan people told the story of a magical girl who turned fierce lions into stars. These became the 3 stars of Orion's belt. The Swana people had another version. They called Orion's belt Dinsa le Dikolob, 3 hunting dogs chasing 3 piglets. The Swana and Xhosa called the Pleiades Selamela or Isilamela, meaning the digging stars, because their appearance signaled the time to plow and plant crops. The Sotho, Swana, and Venda named the Southern Cross and its pointer stars Dithutlua, meaning giraffes, male giraffes for the pointers and female giraffes for the cross. Even the Bushmen named stars in unique ways. They called the red star Antares the fire finishing star, since it shines brightly late at night when campfires die down. Across civilizations, from Babylonians to Zulus, many believed the sky was a great dome, with stars moving on its surface. The telescope changes everything. For thousands of years, people relied only on their eyes. But in 1608, everything changed. A Dutch eyeglass maker invented the very first telescope by using 2 lenses. Suddenly, distant objects looked much closer. 1 year later, Galileo Galilei built his own telescope, powerful enough to make objects appear 30 times larger. For the first time in history, humans could see mountains, valleys, and craters on the moon. Galileo also discovered Jupiter's 4 largest moons and noticed dark spots on the sun. When he looked at the Milky Way, Galileo realized it wasn't just a cloudy band of light, but made of thousands of stars, too faint to see with the naked eye. The telescope had unlocked a whole new universe. How telescopes work so? How do telescopes actually work? Think of them as giant eyes that collect more light than we ever could on our own. A simple optical telescope is made of 2 lenses, the objective lens at the front, which gathers and bends the light, and the eyepiece lens, which magnifies the image so we can see it clearly. This is called refraction because the light bends as it passes through the lenses. But the best telescopes use mirrors instead of lenses. These reflect light up and down the tube, focusing it to make distant objects brighter and sharper. This method is called reflection. Thanks to these innovations, astronomers can see much farther into the universe than ever before. Now that we understand magnification, let's explore how telescopes have helped us unlock the mysteries of the universe. Optical telescopes. Optical telescopes use mirrors and lenses to collect light from distant objects. One of the most powerful in the Southern Hemisphere is SALT, the Southern African Large Telescope. Its mirror is 11 meters wide, and it can detect light from stars and galaxies that are 1 billion times too faint to see with the naked eye. Incredible, right? Telescopes in space. But even the biggest telescopes on Earth have a problem: our atmosphere. The air bends and blocks some light, making distant objects look blurry. That's why scientists launched telescopes into space above the atmosphere to get crystal-clear views. Hubble Telescope. The most famous of these is the Hubble Space Telescope, launched in 1990. Hubble has given us nearly 600,000 breathtaking images, from galaxies billions of light years away to exploding stars. Without Hubble, many of the beautiful space pictures we see today wouldn't exist. Radio telescopes, but light isn't the only way we study the universe. Stars, black holes, and galaxies also give off radio waves. Since our eyes can't see them, scientists use radio telescopes. These huge dishes collect invisible signals and turn them into data and images. South Africa's radio telescopes. South Africa plays a huge role here too, with Cat-7, Meerkat, and soon the world's biggest radio telescope, the SKA, the Square Kilometre Array. When complete, SKA will be able to see so far back in time that it can detect signals from the very first stars and galaxies. Best conditions for telescopes. Of course, where you build telescopes matters. The best spots are high up, with clear skies, little water vapor, no clouds, and no light pollution. That's why deserts and mountains are favorite locations. South Africa's Karoo Desert, for example, has become a world-famous hub for astronomy. Drawing scientific diagrams. And before we wrap up, here's a quick science skill: drawing diagrams. Scientists make neat, simple line drawings of telescopes and equipment to explain their structure. Remember, no shading, use labels, and always include a heading. So, telescopes, whether optical, space-based, or radio, are our windows into the universe. They help us see the unseeable, from the birth of stars to the edge of the cosmos. And the more powerful they become, the more of the universe's secrets we can unlock.